This is a Digital Equipment Corporation PDP-8i, the world's first commercial mini computer. This will be the most difficult project I've ever undertaken in my life to restore this thing into operating condition. It's all wire wrapped. It's an 11-bit computer with 8K of memory, magnetic core memory. It's all plug-in cards. I've got boxes of cards. They contain transistors and 7400 series integrated circuits. Everything is 7400 TTL. Hundreds and hundreds of them. So it's going to be a challenge. The power supply is a special resonant transformer with a capacitor to make sure the power factor is correct. It's got lots of fans, as you can see. There are fans everywhere. I have attempted to restore the power supply, which I've done. I had to replace all the bridge rectifiers. They're all burned out. So they've been replaced. That's the only thing I've done is got the power supply working. Let's see what happens here. Huge filter capacitor banks, monstrous electrolytics. They're a foot tall and 3 inches in diameter. I've replaced all the lamps, they're incandescent lamps, for all the registers, program counter, the memory address, the memory buffer, the accumulator, the multiplier quotient, and all the switch positions. There are lamps for everything, and then including the operation that is actually being done. Now, one hope I have is that the little brother to this PDP-8i is the PDP-8 low cost L. And believe it or not, I actually got this one working. It uses the same card set, so I've got a good known set of cards, which I can then substitute for those one by one to repair them, because the 7400 chips from 1968, which is where they're from, they're prone to failure. So let's just see if I can get this one thing running. All right, load address. Let's see here. I'm not sure what to do here. No, 0200. This is not on all the way. It used to work. Let's see here. Stop. All right, let's see if I can get this started again. So we have to Load address. Examine. It's not running. I don't know why. The problem was I turned the key too far. I turned it into panel lock. If you turn it all the way, you can't do any programming. That's what was wrong. So you have to turn it here halfway. All right, now. Continuous. Let's see here. Load address. Let's see here. 00. Memory address. I think this lock is still... You have to be careful. If you turn it too far... There we go. You see that this switch, you have to be very careful. If you turn it too far, it's locked. All right. I want 0200. 0200. Load address. There we go. 0200. There we are. And run. Here's the run. Start. Oh, there we go. Okay. The program's in core memory, which is this board here. I had one for this computer, but someone smashed it and broke the ferrites. You know, I needed a magnifying glass to get in there, and there's a whole set of matrix diodes, and wedged in there are the actual... I've got several sets of them, but they're all defective. So, anyway... I've got one good set there. Anyway, it's running. So let's stop this now. Stop. Single step. And then you can actually single step program. Anyway, this is running. Okay. Stop. Anyway, I'm hoping to get this computer running. It's going to be a long, complicated thing, and I'm going to have to probably buy several hundred 7400 TTL chips, because I suspect many of them are dead. And I have only one shared memory. I have to be very careful because it's occupying 3 slots. It's very hard to get out because it's stiff. And then you have these cables. You know, if you jar it too much, you risk cracking the thin wires, which are like number 40 gauge wire going through a whole row of cores. There's 4,000 cores on these 3-layer boards. Magnetic core memory. But see, it memorized my program. That's why it was running right away. It's a counting program.